Hello and welcome to our first class on the topic, Coulomb's law. Before going into Coulomb's law, let's see some basic principles. The very basic charging particles are the positive ions and negative ions. These positive and negative ions are accumulated inside the electron. So the number of this charged particles inside the electron is 1.6 into 10 to the power minus 19. So we can call the value of electron as 1.6 into 10 to the power minus 19. Now let's take an atom. The electrons move around the nucleus of an atom. Inside an atom, lot of electrons are present around it. When a certain number of electrons get accumulated in a place, we call it charge. So a charge means there are certain number of electrons inside it. Now let's consider a charge by naming it as small q. So to calculate the charge of q, the number of electrons n is multiplied by the value of electron. Therefore, q equals n into e. Here n is any integer 0, plus or 1, plus or 2, plus or 3, plus or 4 ... This is called quantization of electric charge. Now you know that every charge has a basic charging capability. In 1786, Coulomb found out a formula for the force between two stationary point charges in vacuum or free space. Stationary point charges means the charge is at rest. When charge is at rest, it has the charging capability. So now let's see how he has deduced the relation of force between charges. Coulomb's law is a quantitative statement about the force between 2-point charges. Quantitative means measuring a quantity. That is, it is based on measuring with numbers. Mathematics is used in physics to make models that try to predict what will happen in nature. These predictions are compared to the way the real world works. Consider 2-point charges Q1 and Q2 which are at rest in vacuum. So both charges are at rest. Even in rest stage there are charges of electrons. Now they are separated by a distance of r. So r is the distance between the two resting charges. Based on this, Coulomb found out that the force on the point charge Q2 get exerted by another point charge Q1. So when they come close to one another, a force is exerted between them as F2, 1. Since force is exerted from charge Q1 to Q2, the force is written as F2, 1. R1, 2, is the unit vector which is directed from charge Q1 to charge Q2. A force is coming from Q1 to Q2. So we write the direction as R1, 2. That is from Q1 to Q2, and K is the proportionality constant. All these occurs in vacuum space. So we can write the formula for calculating the force of the charged particles as F2, 1, is equal to Q1 into Q2 divided by r square. Since Q1 is acting over Q2, it is multiplied by R1, 2, vector. The whole setup is in vacuum space. So we multiply by a electrostatic force constant or proportionality constant K, where K is 1 divided by 4 into pi into epsilon suffice 0. Where epsilon suffice 0 indicates its free space. When the linear size of charged bodies are much smaller than the distance separating them, the size may be ignored and the charged bodies are treated as point charges. Therefore, Coulomb's law states that the force of attraction or repulsion between two stationary point charges is directly proportional to the product of the magnitudes of the two charges and inversely proportional to the square of the distance between them. So by using the Coulomb's law, the force between the charges can be found out. Hope you understood the concept of Coulomb's law. Stay tuned to see our videos and learn. Thank you.